Chapter 2, Equation of Straight Lines. Part 3. In this video, I would like to discuss more about the intersections of two straight lines. Let's see example 2.10. In the figure, we have line L. We have another straight line passing through AB and cut L at Q. Part A asks you to find the equation of AB. So part A, maybe you can let y is equal to mx plus c be the equations of AB. Substitutes 3 and 10. So 10 is equal to 3m plus c. And then you can also, we have equation 1 and then substitutes 9 and 20. 20 is equal to 9m plus c. We have equation 2. Use your calculator, you can find m is equal to 5 over 3 and c is equal to 5. Bear in mind, okay, we also need to show some step how to get this answer. Okay, we'll use equation 2 minus equation 1 and then get the answer. After you finding the equation of AB, part B, you want to find the coordinate of Q. And remember, in DSE, in general, we have two methods to find the coordinate. The first one is section formula. That means the formula in your S1. If we know AB and then the ratio between them, I want to find this point. Okay, I have one formula which is called section formula. Another, okay, we try to find two straight lines passing through that point. If we solve this two straight line, then you can find the final answer. Okay, y is equal to 5 over 3 x plus 5. Okay, part B, that means you need to solve 10x minus 9y is equal to negative 15, and then multiply 3 on both sides, and it's 5x minus 3y is equal to negative 15. And then by solving these two simultaneous equations, you can also find the coordinate of xy. So by using your calculator, you can find the coordinate of Q. So Q is equal to negative 6 and negative 5. For exercise 10, you may pause the video and do it by yourself and check your answer later. Maybe you can make good use of your calculator to find the answer. Okay, this is the answer of part A. Write down the two equations by using your calculator. X is equal to 1 and y is equal to negative 5. But remember, you also need to write down the step. In general, okay, this is 3 and this is 7. It is very difficult to make them become equal. So I use 3 times equation 1, that means times the opposite one, and then 7 times equation 2. This is the final answer, part B. Okay, you want to find the equation of L3, and then L3 is a straight line passing through the origin and A. That means this 2 points. So you may let y is equal to mx and c is equal to 0 because y intercept is equal to 0 passing through the origin be the required equation. Set to 1 and negative 5, m is equal to negative 1, negative 5, then done. This is the required equations. What I want to emphasize in this subtopic, maybe some of you will ask, okay, this is some content in junior form. Yes, exactly. In general, if we have two straight lines, they will have one intersection point, but sometimes they do not have. How to determine? Which just depends on the slope of these two straight lines. If the slope of L1 and L2 are not equal, that means they are not parallel. They must have one intersection point. Example 2.10. In each of the following questions, find the number of point of intersections of the straight line L1 and L2. Let's see L1 and L2. Part A. If you only need to determine the number of point of intersections, that means you only need to consider the slope. The slope of L1 is equal to, make y be the subject. I can add 2y on both sides and then eliminate and divide by 2. So slope of L1 is equal to 1 over 2, which is the coefficient of x. How about slope of L2? Same idea, minus 4y on both sides and divide by 4. So which is equal to 3 over 2 is not equal to 1 over 2. So they have one intersection point. Let's see part B. Slope of L1 is equal to 3 over 4. And then slope of L2, make y, typo, this is equal to, it's negative 12y plus 3 and plus 9x. And then make y be the subject, so plus 12y on both sides and then divide by 12. So 9 over 12, which is equal to 3 over 4. They are equal. In this case, how many intersection points of L1 and L2? Which depends on, are they passing through the same y-intercept? If the y-intercept are equal, that means infinite many point of intersection. If the y-intercept are not equal, that means they do not have any intersection point. So find the y-intercept of L1, which is equal to negative 5 over 4. And then y-intercept of L2 is equal to negative 11 over 12. They are not equal. So they do not have any intersection point. If the y-intercepts are equal, that means they have infinite many intersection points. This is the main focus in example. In part 3, we want to determine how many intersection points there and how to find the intersection point. If they have intersection point, if I want to find the coordinate of the intersection point, that means you can solve it by using simultaneous equations.